So in this review, we're going to focus not only on the drinking water treatment, like leading up to filtration, but also those introductory bits from the time that we spent before. So 1, are MCLs enforceable? So I think you need to remember or ask yourself first, what are MCLs? So MCLs, they are maximum contaminant levels. And are they enforceable? Yes. All right, health effects. Health effects, are they associated with primary standards, secondary standards, or both of them? So are health effects associated with primary standards? The answer is yes, absolutely. What about secondary? That's a definite no. Secondary relate to aesthetics. If you were asked to identify 3 inorganic contaminants with MCLs, could you do it, or could you guess? So you've got a list. So inorganics, nitrates are covered. We know that arsenic is something that we should be mindful of, and you might think of another particular metal like copper or cadmium. What are 3 organic contaminants? You can look at the list. There's a bunch, but many of them have obscure names. I probably won't ask you for that like on the exam or anything, because we didn't really hit that too hard. Are viruses like Giardia or Cryptosporidium permitted in water? Are they allowed to have them? What does the standard say? So 99.9% or 99.99% reduction. So that still leaves the potential that Giardia and Cryptosporidium and some viruses can actually go through the drinking water treatment process and still be acceptable. So we regulate those through our turbidity standards. So what are the units for turbidity? The units are NTUs, or nephelometric turbidity units. And what's the maximum turbidity level permitted in surface waters? So at no point should the surface water sample be above 1.0 NTU. Now, the majority of the time though, the samples need to be below 0.3 NTUs. So if you go over 0.3, it should be a rare event. All right, number 3, water treatment involves intake, clarification, and disinfection. So what are the 4 steps in clarification? We didn't really cover that too much, but you can probably guess it. So we've got coagulation, flocculation, filtration, and I forgot one. Coagulation, flocculation, sedimentation, and then filtration. How do water plants deal with clogged screens? Or first, what are the 2 major causes for water plants to have their screens clogged? So just think of a couple. You can think of like algal mats and the growth of like algae. So if it's in a photic zone, their intake, it can get covered up with a lot of photosynthetic green slimy stuff like algae. Also, another biological cause could be mussels, like zebra mussels or some other type of barnacle type thing attaching to them. So those are just 2. All right, getting into the review on the chemicals. So what's the main chemical used for coagulation? So the main chemical element. And that's aluminum. Aluminum's got a positive charge to it, and it does a good job binding with negatively charged stuff that comes from the water plant. What chemical enhances coagulation? It's not the coagulant. It enhances it, particularly by raising the pH and raising the alkalinity when needed. So what chemical raises the pH and alkalinity? And that answer would be lime, calcium carbonate. Number 3, the rapid mixing of water. Is that coagulation, flocculation, or sedimentation? You have to think those paddles, the flash mix is associated with coagulation. It's the addition of the coagulant. We want the coagulant to bind with stuff. That mixing is coagulation. Flocculation, we slow it down and allow the flocks to form. Sedimentation, we really slow it down and allow the flocks to settle into sludge. Number 4, what's the name of the test that can be used by a water plant to figure out how to optimize their coagulant chemical composition? So they don't want to waste too much coagulant. They want to have the right amount of lime and the right amount of aluminum compound. What's that test called? Usually there's 6 jars called the jar test. Our next video, we're going to get into the different types of media that can be used, and what are 3 types of disinfection used in the drinking water treatment industry. We'll get to that later. Our total coliforms permitted in treated water. So from a previous set of slides, you would know that, yeah, they are, but we don't want them there, and they shouldn't be there for more than 2 consecutive days, and they shouldn't be there at 5% or more of your samples in a given month. Number 4, what city had the largest recorded waterborne disease outbreak in history? So you should have seen a video on this, and that was Milwaukee, Wisconsin. And what caused the outbreak? That outbreak was caused by Cryptosporidium. Was it human or animal? And you should remember from the USDA scientists that analyzed the stool specimens that they determined it was from Cryptosporidium hominis rather than Cryptosporidium parvum. So hominis, meaning it came from the humans. It was the human type of crypto, not the animals that were initially blamed. So it was probably linked to actually a combined sewer overflow event in the 1993 time during some heavy rains. So our next videos, we're going to get into filtration, then we'll get into disinfection. So I'm going to stop here for the review.